Okay, hello dear friends, such a beautiful, beautiful day. And we will keep on doing our mathematics. It's kind of addicting when you get into it. And we do 73 and follow on. So I will copy this problem, tangent, cosine, inverse of 4 over 5. So 73 tangent cosine. Oh, that is a capital C. So it's on the Capitol Hill. It's one of those one of a kind. When people goes to Capitol Hill, it's one of a kind. So there is a domain, there is a particular domain and a particular range for it. So this is a unique value. There is not a repeating value. Yesterday we talked about it because this is capital. When this is a lowercase letter, so it's a circular function's result, and the number can vary, but once it is a capital, it is one particular value. So first we see cosine inverse of 4 over 5. We know the cosine domain for this inverse function, domain is 0 to pi, right? 0 to pi, this is its domain. And if it is a positive value, so this is in half pi, before half pi. And it's we can draw it in a quadrant. In a quadrant, this one is in the first quadrant. And we have such an angle. And cosine for, this is the angle theta. The cosine is adjacent in comparison with hypotenuse, right? So once we draw this one, we already know this 勾三股四玄武 3, 4, 5. This is the most important number in trigonometry. And for many thousand years ago, Chinese already got it 勾三股四玄武. So when one line, one side is 3, another side is 4, and the hynopsis is hypotenuse, not hynopsis. Hynopsis, what is hynopsis? It's not my language anyway. Hypotenuse is 5. So this is a Pythagorean theory also. So we know this one is 3. This one is not given, but we figured it out. We figured it out from Pythagorean theory. So first, if we dismantle this problem, cosine negative 4 over 5, we need to find an angle that so that cosine theta, here this is a theta, and the theta, the cosine is 4 over 5. It is 4 over 5. And through this value, we can figure out the opposite side of the angle theta. Now we need to figure out tangent of theta. Tangent of theta is opposite side over adjacent side. So it's 3 over 4. When you see this, it becomes much clearer and easy, right? Okay. Now, 75 sine tangent. Ooh, take a look here. This is a capital. Something in the capital is one of a kind, right? Someone in the capital who can go to capital is one of a kind. There's no exception in mathematics. So what we are seeing here, this is an angle. This is angle theta. Once upon a time, there was an angle. And in tangent, if this is positive, so it must be in first quadrant. So we can draw this angle in the first quadrant. And we know here is the theta and the opposite over adjacent. So we can figure out this one, right? 5 squared plus 12 squared equal 25 plus 144 equal 169, right? And 169 is the square root of 169. So it's 13th square. So this one is 13. This is another trigonometric specific or special angle. 5, 12, 13. Remember it. Before you die, remember it. Anybody ask you, one side is 5, another side is 12, and the rest side, how many it is? There's no choice. It must be 13, the miserable number 13. Okay? Remember it. So we know the angle theta. Theta is like this. So tangent theta, we better do exactly the same. Tangent theta equal to 5 over 12. So we know this one, and we know the theta. The theta, we cannot write it on how many degrees. You can write it definitely through decimal or through your graphic calculator. But instead of writing a degree number, I will use this value to continue to do the calculation. So sine theta equal to, sine is opposite angle over hypotenuse. So it's 5 over 13. Is that clear? Because this one is in the first quadrant. This one is capital, so it's defined within a certain range. It's a valid range. So we know there is only one value for the theta, the angle theta, and then we continue to do it. Make sense? Okay, now we will do question 77. Question 77. This might be a little bit complicated because there is a negative value here. Okay, did you see it clearly? I will copy the problem. So 77 is cosine arc sine negative 8 over 17, right? Negative 8 over 17. Okay, for this we need to take a look at our sine. So where is the domain? This is the domain. This is 0, negative half pi to positive half pi, pi over 2. So this is the domain. Because it is continuous and have all the y value And here, because it's a circulate function, so it's always continuous, repeating this number. So we choose one area, one domain that only reflect only in here, instead of writing all these numbers. Okay, so arcsine, we know it's a negative angle, right? And it's in the fourth quadrant because it's a... So what we can do, we can draw it like this. Here we have an angle theta, and sine is the y value, or the opposite of theta, over the hypotenuse. And, oh, it's not negative, because this y value is negative. So the theta value is negative 8/17. Now, forget about anything. We need to figure out this one, right? 17 squared minus 64, or 8 squared, equal to 289 minus 64, equal to 225, equal 15 squared. So this one is 15. Positive, negative, here is positive, here is negative. And this one is a scalar value. It never has positive or negative hypotenuse. So this one is positive. So now we need to figure out, we know this angle is such. So cosine of this angle is, we do not need to know the degree of it, although we can figure out the degree through graphic calculator. But what we need to know is the cosine of the side relationship. Cosine is adjacent, which is 15, and it's positive 15/17. And that is the value we figured out. And this is the correct value. I know it. If you do not believe me, let's check the answer. This one is 77. See, 15/17. We are right. Okay. We are always right. We are just right.